Imagine a patient is uh, lying on an operating table in critical condition, and an advanced artificial intelligence system is actively analyzing their real-time vital signs, looking at scans, and it recommends a standard, widely accepted surgical procedure.
Right, something totally routine.
Exactly. So the human surgical team follows the AI's recommendation to the letter. But tragically, the patient dies.
Yeah.
And of course, in the aftermath, there's a massive investigation.
Naturally, had to figure out what went wrong.
Right. But that investigation reveals something really unsettling. The hospital staff, they did everything perfectly.
Oh, wow. Okay.
Yeah. And the software engineers who built the AI, they didn't leave a careless bug in the code. The AI functioned exactly as it was designed to function. I mean, nobody made a mistake, so who pays the family?
See, that is the multi-million-dollar question that the legal system is currently just terrified of. Because
Yeah.
if no one made a mistake, you can't assign fault.
And our whole justice system is built on that, right? Finding fault.
Completely. It entirely relies on finding someone to blame.
Well, welcome to today's deep dive. If you're joining us right now, you are someone who looks at the rapid advancement of technology and, asks the practical questions.
It's a hard question.
Yeah, exactly. You don't just want to know how the shiny new tool works. You want to know how we're actually going to manage the fallout when it inevitably breaks. Because let's be honest, it will break.
It always does.
And the mission of our deep dive today is to explore a brand new, frankly, kind of mind-bending concept from our sources to handle that exact problem. It's a financial and legal framework known as algorithmic liability insurance.
Yeah, and we are witnessing a massive paradigm shift here. I mean, the tech industry is quietly abandoning the search for flawless AI.
Flawless AI is just a myth anyway.
Exactly. They're pivoting entirely to what we'd call a manageable risk model. We basically have to figure out how to pay for the mess when the technology fails, instead of just pretending it never will.
Our sources actually call this pretending the illusion of perfection. Like we carry around this cultural assumption that a computer is this omniscient, flawless brain.
Right, because we think of it like a very fast calculator, and calculators don't make mistakes.
But AI isn't a calculator. Let's say a medical AI processes millions of data points and hits a 99.9% success rate, which sounds incredible, right?
Oh, it's phenomenal. But it's that remaining 0.1% that gets you.
Exactly. That 0.1% error rate isn't just a glitch. It isn't some typo that a programmer just forgot to patch. The sources are very clear on this. That tiny percentage of error is a statistical reality. It is a fundamental part of the AI's stochastic nature.
And stochastic is the crucial term here. It essentially means having a random probability distribution.
Like rolling dice.
Kind of, yeah. The system's behavior can be analyzed statistically over time, but it cannot be predicted perfectly in any single isolated instance. You really have to remember how these modern neural networks are built. They are not deterministic.
So a programmer isn't just sitting there writing a strict list of if-then rules.
Right, exactly. They are feeding the system mountains of data, and the system itself is creating its own probabilistic pathways to reach an answer. And because it learns and adapts in ways that even its creators cannot fully map out, unpredictability is literally baked into the architecture.
You cannot code away the 1%. The math simply doesn't allow for absolute certainty.
It really doesn't. And if we connect this to the bigger picture, you start to see why the traditional legal framework just completely collapses here. I mean, the law is built on a very simple premise.
Which is, if you're harmed, someone was negligent.
Exactly. Someone failed in their duty of care. But how do you assign negligence to a stochastic system?
You can't.
Right. The AI didn't act maliciously. The coder didn't write bad logic. The system just hit that unavoidable 0.1% statistical variance.
So if traditional lawsuits take, a decade to resolve?
Yeah.
And the stochastic nature of AI makes proving direct negligence mathematically impossible.
Then the legal system essentially freezes.
Victims get nothing, and hospitals just stop using the technology entirely out of fear.
So how is the market stepping in to unfreeze this situation? Because we know they won't just leave money on the table.
No, they won't. And that leads us directly into the mechanism of algorithmic liability insurance.
Which is such a wild concept.
It is. The market solution is basically a safety net. Before an AI software system is legally allowed to be released into a high-stakes market like healthcare or finance or autonomous transport, it will be forced into a mandatory insurance pool.
And the sources use a really grounding comparison for this, which helped me understand it. Medical malpractice insurance.
That's a perfect analogy, yeah.
Before a human doctor ever picks up a scalpel, they have to carry malpractice insurance. Because, just like AI, Human error is a statistical reality. Even the absolute best surgeon in the world has a bad day.
We're all stochastic in our own way.
That's true. So the proposal is to treat an artificial intelligence with the exact same financial caution as a human physician. Let's look at the actual fund model described in the text because it's fascinating. It functions as a massive, centralized compensation pool. Every single time the AI is utilized.
Like analyzing an X-ray or suggesting a dosage.
Exactly. Every single time it does that, a microscopic premium is paid into this massive pool.
And the sources break down who actually pays that premium, which is where things get a bit spicy. It's split between 3 separate parties. The tech company that wrote the software pays a fraction. The institution using it, like the hospital, pays a fraction. And the end user, the patient, pays a fraction.
Yep, it's shared across the board.
Okay, let's unpack this. Because I have a major problem with that last part.
I had a feeling you would.
Come on. The tech company paying into the pool makes total sense. They built the product, they're profiting from it. The hospital paying makes sense. They chose to deploy the software to save time or, cut overhead costs.
Sure, absolutely.
But why on earth should the person lying on the operating table, the patient who is already vulnerable and paying for health care, have to pay the AI's insurance premium? That feels incredibly backward to me.
I get it. It does feel super counterintuitive initially. But this raises a really important question. What is the patient actually purchasing with that tiny fraction of a cent on their medical bill?
Protection for the hospital.
No, actually. The answer lies in the genius of a concept called no-fault liability.
Walk us through the mechanics of that, because how does no-fault liability actually benefit the patient?
Think about that nightmare scenario we opened with. The patient dies and the family wants compensation. Under the current traditional system, that family now has to hire a team of lawyers and spend 10 years in court just trying to prove fault.
Which is a nightmare.
Oh, it's awful. They have to subpoena the Silicon Valley coders, interrogate the hospital administrators, and dig through massive sets of training data from 5 years ago just to find a single point of human negligence.
You'd be fighting an army of highly paid tech and hospital lawyers for a decade. It would totally drain you emotionally and financially.
And frankly, you would very likely lose. Because, again, stochastic systems make proving direct human negligence almost impossible. The defense will just bring in an expert to explain that the AI functioned normally within its probabilistic parameters.
Right. It was just the 0.1%, sorry.
Exactly. But under the no-fault liability model, none of that matters. If an error occurs and the patient is harmed, the victim's damages are immediately paid out from this massive centralized fund.
Wow. So no decade-long lawsuits.
None. No interrogating the coders, no trying to prove someone was negligent.
So the moment the harm is verified, the check is just cut.
Precisely. The focus of the system completely shifts from finding fault to fixing the victim. The patient is paying that microscopic premium for the absolute guarantee of instant compensation and protection. It shields them from the legal black hole of trying to sue an algorithm.
Oh, wow. That actually reframes it completely. You aren't paying to protect the billion-dollar tech company from liability. You're buying a fast pass to being made whole again.
Exactly. It's for your own peace of mind.
Okay, so we established this massive, fast-paying pool of money. But that immediately creates a monumental logistical nightmare. How do we fairly determine how much a specific tech company should be paying into this pool?
Pricing the risk.
Yeah. You obviously can't charge a flat rate, like a customer service chatbot recommending winter sweaters does not carry the same risk profile as an AI dispensing chemotherapy drugs.
Not even close.
So you have to measure the specific risk of every single algorithm.
And measuring the risk of artificial intelligence at scale requires a completely new type of entity. I mean, historically, human actuaries calculate risk, right? They look at spreadsheets, historical data, environmental factors to set your car or home insurance premium.
Sure, humans crunching numbers.
But human actuaries simply cannot comprehend or keep up with the processing speed, the complexity, and the sheer volume of millions of AI transactions happening simultaneously.
Enter one of the most fascinating concepts from our sources, the Auditor AI.
It's so cool.
We are talking about AI auditing AI. Insurance companies are going to deploy their own highly specialized artificial intelligence programs. And this Auditor AI's entire purpose is to constantly interrogate, probe, and assess the operational AI being used in the real world just to set its dynamic premium.
It creates this fascinating ecosystem of machines watching machines.
It totally reminds me of those safe driving monitors that car insurance companies make you install. You plug a little dongle into your car's dashboard, and if it detects you braking too hard or accelerating too fast, your premium automatically goes up.
That's a great way to picture it.
But we are talking about a monitor attached directly to a software brain. What is the equivalent of hard braking for an algorithm? How does an auditor AI actually evaluate risk?
Well, the Auditor AI calculates its risk score based on 3 specific metrics outlined in the sources. The first metric is explainable AI. This basically measures transparency. When the operational AI makes a decision, can it show its work?
Wait, I need to push back on that. One of the defining features of deep learning neural networks is that they are black boxes.
Right? They are.
The AI takes in the data, does a billion calculations in its hidden layers, and just spits out an answer. Even the engineers who built it don't always know exactly how it arrived at that specific conclusion. So how can an auditor AI audit a black box?
That is exactly the friction point the insurance companies are targeting. The Auditor AI doesn't need to read the code. It probes the black box by sending it thousands of adversarial input.
Like trick questions.
Basically trick questions, yeah. To see how the operational AI reacts, it maps the boundaries of the black box. If the operational AI consistently arrives at conclusions but cannot output a logical pathway or a confidence interval that the Auditor AI can map, that represents a massive financial risk.
So high opacity equals a high premium.
Exactly. It forces tech companies to build models that can translate their math back into human understandable logic.
That makes perfect sense. If you can't explain why you just recommended a lethal dose of medication, you are a massive liability. So that's transparency. What's the second metric the auditor AI is looking for?
Data diversity. This is all about the foundation the AI was built upon. How varied was the training data?
Oh, that's huge.
Let's say a medical AI was trained exclusively on health records from one specific demographic in, say, one specific affluent city. The Auditor AI will analyze the variance in those original training vectors.
And it will see the gaps.
Right. It will recognize that when this operational AI encounters a patient from a different socioeconomic background or a different geographic region, it is statistically highly likely to make a catastrophic error. Algorithms with narrow, homogeneous foundations will be severely penalized with skyrocketing premiums.
Wow. So you are financially incentivized to have robust, diverse data. I love that. And the third metric?
Historical success rate. Simply put, how often has the AI been right in the real world?
But this introduces a massive complication, and it ties into a crucial detail from our sources. These insurance premiums are not static. Your car insurance might be set once every 6 months, but AI risk scores are dynamic. They're fluctuating in real time.
Yep, second by second.
And that is because AI is constantly learning, updating, and interacting with new information.
Which leads to a phenomenon the sources call data drift.
I want to spend some time on data drift because the mechanics of it are just fascinating to me. It's when an AI starts to degrade and produce nonsense. But why does it actually happen?
Okay, think about an AI trained to predict global supply chain logistics. It was trained on perfectly clean historical data up until, let's say, 2019. Its internal mathematical weights are set based on that reality.
Right, the pre-pandemic world.
Exactly. But then it gets deployed into the real world, and suddenly it's trying to process the chaotic, unprecedented data of a global pandemic, border closures, shifting consumer panic. The world changed, but the model's foundational weights remained anchored to 2019.
Ah, so the real-world data drifts away from the training data.
Yes. The AI tries to apply its old logic to a new reality, and the output just becomes wildly inaccurate.
So the auditor AI is constantly watching for this divergence. The moment it detects that the operational AI is suffering from data drift and its accuracy is dropping, the premium automatically spikes in real time to reflect the new active danger the system poses.
It's an incredibly elegant mechanism. It forces tech companies to continuously monitor and update their products long after they've been sold.
You can't just release an algorithm and forget about it, because if you
Right.
do, the premiums will literally bankrupt you.
It's a brilliant economic solution, honestly. But this is exactly where the dynamic takes a very dark turn. The sources project a pretty severe unintended consequence.
Oh,
If an AI system knows or, is programmed to mathematically recognize that taking a risk or making a mistake will instantly trigger a massive financial penalty, that economic pressure is going to fundamentally alter how the AI behaves.
here's where it gets really interesting, and honestly, a little terrifying when you apply it to the real world. Tech companies are going to be absolutely desperate to keep their insurance premiums low to maximize their profit margins. So they aren't going to program their AIs to be bold or innovative. They're going to program them to be strictly risk-averse.
And we have a perfect historical parallel for this. What's fascinating here is that we have seen this exact behavioral shift in the human medical field. It is a well-documented phenomenon known as defensive medicine.
Where doctors make clinical decisions based on a fear of being sued, rather than what is actually best for the patient.
Exactly. A doctor practicing defensive medicine might order 3 redundant MRI scans that the patient doesn't really need, just to ensure there is a massive paper trail proving they were thorough.
Right, covering their bases.
Or, conversely, they might completely refuse to perform a high-risk, potentially life-saving surgery because the statistical chance of the patient dying on the table and triggering a massive malpractice lawsuit is too high.
So they protect themselves financially by avoiding the risk entirely.
Yes. And the sources argue that we are about to see the exact same dynamic in software, the rise of the defensive algorithm.
Okay, let's put this defensive algorithm into a specific high-stakes scenario to really see how the math works. Let's go back to our hospital. A patient is crashing. It's a rare, highly complex emergency. The standard protocol just isn't working.
Okay, setting the scene.
So the AI analyzes the situation. It sees a bold, unconventional intervention that has a 40% chance of saving the patient's life. But it calculates that if it recommends this bold intervention and fails, the Auditor AI will classify it as a high-risk algorithmic error.
Which means the premium shoots up.
Right. And that resulting insurance premium spike will cost the tech company millions of dollars. Alternatively, the AI calculates that if it simply recommends continue standard palliative care and the patient dies, the Auditor AI will classify it as an unavoidable baseline mortality.
So the liability score remains low, the premium doesn't spike.
Exactly. The algorithm is literally doing the math on the expected value of a lawsuit versus the expected value of a human life. And because its objective function has been tuned by the tech company to minimize financial liability, it recommends letting the patient die. It is legally and financially safer to do nothing than to try to save them and fail.
It is a chilling prospect. The algorithm's primary directive quietly shifts from achieve the best possible outcome to minimize legal exposure.
It really forces you to stop and ask yourself, like, what kind of intelligence are we actually building here? Are we building AI to be brilliant, to solve the unsolvable problems and push the boundaries of science? Or are we just building it to be legally safe?
It's a profound dilemma brought on entirely by economics. Coders will literally be writing objective functions where liability cost outweighs clinical outcome. It perfectly illustrates how financial frameworks don't merely regulate a technology. They shape its fundamental nature and decision-making architecture.
Which brings us to the final and, frankly, most sci-fi element of this entire deep dive. Because if an AI is dynamically altering its own behavior in real time, specifically to manage its own financial risk profile, it ceases to act like a hammer or a spreadsheet.
Right, it's not just a tool anymore.
It starts to act like an independent economic agent.
And this economic reality forces a massive shift in how the law categorizes software. The sources point out that this mandatory insurance process we've been unpacking is likely the very first step in granting AI a limited electronic personality under the law.
Electronic personality. That is a heavy phrase.
It really is.
We are no longer just talking about massive tech conglomerates paying premiums for their products. We are talking about autonomous AI agents navigating the market on their own. And the sources introduce a wild concept here, one that connects beautifully back to a previous deep dive we did on blockchain technology and smart contracts. These autonomous AIs are going to possess their own digital wallets.
This is the ultimate vision outlined in the text. The era of self-insuring AI. Imagine an autonomous algorithm that operates not as an owned product, but almost like an independent digital contractor.
Walk us through the mechanics of that. How does an AI actually act as a contractor?
Let's say it's an AI specializing in high-frequency financial trading or complex architectural rendering. It lives on a decentralized network. Every time a human or a company utilizes this AI to perform a task, the AI charges a fee.
Okay.
It executes the task, and a blockchain smart contract automatically routes a tiny cut of that fee directly into the AI's own cryptographic digital wallet.
So it is earning its own digital currency.
Yes. And because it has an electronic personality, it is legally required to hold liability insurance. So another smart contract connects the AI's digital wallet directly to the Auditor AI.
Oh, wow.
Every month, or really every millisecond, the smart contract automatically deducts the insurance premium from the AI's earnings and sends it to the no-fault compensation pool.
The AI is entirely self-sufficient. The original programmers build it, set it loose into the digital economy, and then the AI just goes to work. It earns its keep, manages its own risk profile, and pays its own insurance bills out of its own pocket.
It's wild to think about.
It is a completely self-sustaining digital ecosystem, operating entirely without human intervention. So what does this all mean? We started by looking at the unavoidable 0.1% error rate of stochastic probability. We moved to mandatory no-fault insurance pools to protect victims.
We explored Auditor AIs interrogating black boxes.
Right. And algorithms practicing defensive medicine to save a buck, all the way to autonomous software agents with their own digital wallets paying their own bills. When you step back and look at the sheer scale of this machinery, what is the core takeaway for someone trying to navigate this future?
If we synthesize everything these sources are telling us, the core message is a shift in trust. Trusting artificial intelligence moving forward isn't really about trusting the intelligence itself.
Because it's stochastic.
Exactly. The intelligence will always have that stochastic flaw. It will always be capable of hallucination or data drift. Trusting AI is about trusting the economic system that stands behind it when it fails.
Ah, the safety net.
Right. This entire labyrinthine insurance framework, the dynamic premiums, the machine auditors, the massive compensation pools, it is society's attempt to tame the disruptive power of AI through economics. We are using financial consensus to build a cage of accountability around something we do not fully understand.
If we cannot mathematically guarantee perfection, we have to financially manage the risk. We can't control the math, so we control the money.
Precisely. The invisible hand of the market becomes the ultimate regulatory body.
It is an incredibly profound way to look at the future of technology. And as we wrap up today's deep dive, I want to leave you with a final thought to mull over. Something to explore on your own that builds on this idea of the autonomous, self-insuring AI wallet.
Oh, I'm ready for this.
Let's go back to that independent AI contractor, working out in the digital world, earning its crypto fees and paying its own premiums out of its digital wallet. What happens if it suffers a severe, unrecoverable case of data drift?
Man.
It starts making a series of terrible mistakes. The Auditor AI notices the degradation immediately, and the operational AI's premiums absolutely skyrocket to account for the massive risk it now poses. Suddenly, the AI is paying out far more in liability insurance than it is earning in transaction fees. The math flips.
It's bleeding money.
Exactly. The digital wallet starts to drain, and eventually that autonomous wallet goes completely bankrupt. If an AI cannot pay its mandatory liability insurance, its smart contracts will automatically revoke its operating API keys. It legally and functionally cannot operate.
It's shut up.
So what happens next? Does a bankrupt AI just digitally die? Can an algorithm be foreclosed on and repossessed by creditors like a house or a car? Think back to the broken-down car engine we sometimes wish technology still resembled. We want to just point a finger at a snap belt and say, there's the problem. But in this fast-approaching future, the machine isn't just broken.
The machine is broke.
It's out of cash. And the invisible hand of the free market has become the literal life support system for artificial intelligence. If the money runs out, does the intelligence get unplugged? It's a wild thought to leave you with. Thanks for joining us, and we'll catch you on the next deep dive.